I have 1 by x dx is log x, then integral of 1 by ax plus b dx would be 1 by coefficient of x, which is a. So 1 by a log ax plus b is what we get. Integral x power n dx is x power n plus 1 by n plus 1. Then my integral of ax plus b whole power n dx is nothing but 1 by a of ax plus b whole power n plus 1 by n plus 1 is how I compare the general formulae with the function in the form ax plus b, the linear function. Next, taking some trigonometric functions, I get integral of sin x is minus cos x, and then integral of sin ax plus b is 1 by a of cos ax plus b is how we get. And similarly, integral cos x is sin x, in the sense integral of cos ax plus b is 1 by a times sin ax plus b. And then integral of secant square x is dx, secant squared x dx is tan x. Then integral of secant square ax plus b dx would be 1 by a times tan ax plus b. And then up next is cosecant square, which we know as cosecant square is minus cot, and therefore cosecant square of ax plus b will be 1 by a of minus cot x, that is minus 1 by a cot ax plus b, etc. So this is how every standard formula is related to this, or every function in the form ax plus b when reduced to the standard form with ax plus b in place of x is very much connected with the standard formula, with the only difference being that the same formula is going to come out here on the right hand side with x, of course, replaced with ax plus b, but the only difference being that it has coefficient of x in the denominator. So when I do any problem, when I want to find integral of e power 3 minus 2x dx, I simply find integral e power x dx is e power x. Therefore, this is e power x by coefficient of x plus c. That's it. So this is how we do for every problem which involves ax plus b as the function in linear form. Now let's take the function in the form f dash x by root fx. If I have a function in the form f dash x by root fx, then let's see how we can integrate this kind of a function. Integral of f dash x by root fx dx is said to be directly 2 root f of x plus c. Is how we get the formula. Say, for example, I have integral of 6x by root of 3x square minus 2 dx. Then let's see if this particular function is in the form as taken in the formula. So here clearly I take the function inside the root as f of x, and let's see if I get f dash x to be the numerator. So the function inside the root is f of x, which is 3x squared minus 2. I don't take the root because the function only inside the root is considered as f of x. Then differentiating, I get f dash x to be 6x because d by dx of 3x square is 6x minus 0. And then I clearly see that my f of x is 6x. Therefore, this is in the form of f of x integral by root fx dx, as can be compared with this. Clearly, when f of x is taken as this, its derivative gives f of x. Therefore, it is in the form integral f dash x by root fx dx, which is nothing but 2 root fx. And therefore, this, using the formula, is 2 root fx plus c. But my f of x is 3x squared minus 2, which I substitute inside the root. So therefore, we have this formula substituted with f of x equals 3x squared minus 2, and hence integral of 6x by root 3x squared minus 2 dx reduces to 2 root of f of x, which is 3x squared minus 2 plus c. Is how we substitute using the formula and derive for this given problem. So function in the form f dash x by root fx can be derived using the integral of this with the formula 2 root fx plus c. Now let's evaluate integral of tan x dx using the method of substitution. That is, the method of substitution helps us in identifying few of the standard integrals. For example, integral tan x dx. So let's see how we can do this. Now, as we know that integral tan x with tan x equals sin x by cos x can be substituted for tan x in place of, then this reduces to integral of sin x by cos x of dx. So once we substitute the formula for tan x, which is sin by cos, then I use the method of substitution, because in this case, if I take cos x as some t, integration of cos x is minus sin x dx, which helps us using the method of substitution. So let's see if this method helps in identifying the standard formula. So let cos x equals some t. That implies differentiating cos x is minus sin x dx is dt. That implies sin x dx is minus dt, is how we get for cos x and this. So when substituted in the main formula, I get sin x dx substituted with negative times of dt, and cos x, which is t, and minus sign taken out gives this in the form 1 by t dt. Now we know that integral of 1 by x dx is log mod x plus c, which on substitution gives us integral 1 by t dt is minus of log mod t plus c. That is, when I take this in the form of t, which is cos x, so in place of t, substituting with cos x plus c further reduces using minus inside. This can be written as mod of 1 by cos x plus c, because we know that log of A inverse is minus log A, is how we substitute for this formula. And we also know that reciprocal of cos is secant. Therefore, using cos x equals secant x, I get this as log mod secant x plus c, which is integral of tan x dx being log mod secant x plus c. Therefore, the standard formula integral tan x dx can be derived using the method of substitution, and hence we obtain integral tan x dx as log mod secant x plus c. method of substitution helps in finding the trigonometric formulae. Similarly, integration of Cortex is proceeded with the same steps as that of tan x. Suppose integral of Cortex is to be evaluated, then we take this with the formula cos x by sin x of dx, because cot x is cos by sin, and then the substitution sin x equals t implies cos x dx is dt. Therefore, this reduces to t in the form of dt by t. Now, integral of 1 by x dx is log x. Therefore, I get log mod t plus c. Log mod t is nothing but log mod of sin x plus c. Therefore, integral of cot x dx as log mod sin x plus c is how we identify the standard formula of integral cot x. Next is integration of secant x. Say I wanted to integrate secant x dx, then we don't have any formula for secant. Of course, if we write secant as 1 by cos, that doesn't help in evaluating this. So let's try with some other method where I multiply and divide with secant x plus tan x. So denominator with secant x plus tan x and numerator with secant x plus tan x dx. So with multiplying and dividing with this factor, let's see if this helps in identifying the formula for integral secant x dx. So for this, I substitute the denominator secant x plus tan x equals sum t, and differentiating on both sides, d by dx of secant x is secant x tan x, and d by dx of tan x is secant square x of dx equals dt. And again, we see that secant x is common, and then taking secant x common, I get here secant x plus tan x dx equals dt. Therefore, I see that the whole of secant x times secant x plus tan x dx is dt, which we get out here. So substituting, I get this to be integral dt by secant x plus tan x, which is t. So the substitution helps in reducing to 1 by t times d of t integral, which is nothing but log mod t plus c, that is log mod of t, that is secant x plus tan x plus c, is how we identify the formula of integral secant x dx, which is log mod secant x plus tan x plus c, using method of substitution. Next is integration of cosecant x, where I get integral of cosecant x dx. Proceeding in the similar manner as that of secant x, I multiply and divide with cosecant minus cot by cosecant minus cot, and then on substitution of the denominator equal to t, this reduces to integral f dash x by f of x, which is log mod f of x. So therefore, using the formula f dash x by fx, we get this as log mod f of x, that is cosecant x minus cot x plus c. Therefore, integral of cosecant x dx is log mod cosecant minus cot plus c, is how we identify the standard formula for integral cosecant x using the method of substitution. Now next is integration of secant x in terms of tan. Let's see how we can express in terms of tan x. So here we try to derive a formula which sometimes is useful in terms of tan. So integration of secant x is already found to be log mod secant x is found to be this, but it has another formula which we need to know is log mod tan pi by 4 plus x by 2 plus c. This formula helps sometimes when we demand for the answer in tangent of the function. So therefore it is equally important that we have two basic formulae, one in terms of tan and one in terms of secant plus tan, is how we identify the formula in terms of tan. Similarly, we identify the integration of cosecant x also in terms of tan. Say integral of cosecant x dx is found to be log mod cosecant minus cot plus c, which in terms is log mod tan x by 2 plus c, is how we derive the formula in terms of tan. So integration of cosecant x is log mod tan x by 2 plus c. Now let's see some problems which are related to the standard formulae which we have derived for tan, cot, cosecant and secant x. So for example, I have a problem where I need to find integral of 1 by sin x cos x dx. Then how do I find integration of this function? Because this is not in the standard form, we try to utilize some algebraic properties to reduce this into the standard form. So let's try integrating 1 by sin x cos x. Now here we see that clearly there is no trigonometric term in the numerator. I can write the formula sin square x plus cos square x is 1, which we have in the formulae of trigonometry. So in place of 1, I substitute sin square x plus cos square x. So 1 reduces to sin square x plus cos square x by sin x plus cos x dx, is how this function reduces to the new function. Now let's see what further can be done with this to reduce that function into the standard form. So here I clearly see that I can split each of the terms with sin square by this plus cos square by this, and hence I get this as sin square by sin x cos x dx plus cos square by sin x cos x dx. Now this, on further simplification, I can cancel one of the sin x here and I can cancel one of the cos x out here. Therefore this simplifies next to integral sin by cos plus integral cos by sin. Which on further simplification, as clearly we can identify that sin by cos is tan, therefore this reduces to tan x dx plus cos by sin, which is cot x dx. Now let's recap with what we have learned in the previous sessions. We have identified the formula for integral tan x as log mod secant x, and integral cot x is log mod sin x plus c, is how we get the formula. So using the formula for tan x and cot x, we get log mod secant x and log mod sin x, which can be further simplified because I have log a plus log b is log a times of b, and therefore log of this plus log of this is log of secant x times sin x plus c, and this can be further simplified to be log mod secant is 1 by cos, and this is sin plus c, and hence sin by cos is tan, so this can be written as log mod tan x plus c is what we get. The answer for integral of 1 by sin cos dx is log mod tan x plus c using the integration of tan and cot as a standard formulae. Next, let's see the process of integration where I substitute a trigonometric angle. Sometimes the algebraic equations or the rational functions need to be substituted with a trigonometric angle to reduce the given integral into the standard form. So this plays a vital role in many integration problems, and hence let's discuss this session with substitution of a trigonometric angle. Say for example, I have integral of x squared by root 1 minus x squared dx, which I need to integrate using the standard formulae. Now the direct method of substitution of 1 minus x squared equal to t does not help, because if I take 1 minus x squared as t, then the derivative reduces to x, but I have x squared. So the method of substitution of t does not help out here. Let's try with trigonometric angle substituted. Now as we know that sin square theta plus cos square theta is 1, then cos square theta is, or sin square theta is 1 minus cos square theta, that this helps us in comparing 1 minus x squared with 1 minus cos squared. So the trigonometric substitution of x equals cos theta will help us, because this reduces directly to a square term, and root of a square term directly gives us sin theta. So sometimes we need to substitute the trigonometric angle as compared with the rational function. So x equals cos theta implies differentiating dx as d by dx of cos theta is minus sin theta d theta. So which substituted here reduces to integral of x squared, that is cos squared, and root of 1 minus x squared 1 minus cos squared, and dx is minus sin theta d theta. And then this on next further simplification gives us minus integral sin theta cos square theta by root of 1 minus cos squared, which is sin squared, and therefore root of sin squared is sin, therefore I get this as sin theta cos square theta by sin theta d theta, which finally reduces to cos square theta d theta, but I don't have the formula for cos squared, but I can reduce this using the trigonometric properties. We know that cos squared is 1 minus cos 2 theta by 2, and sin squared is 1 plus cos 2 theta by 2. Cos 2 theta is plus. So I get this to be minus of the whole thing substituted here gives minus integral 1 plus cos 2 theta by 2 of d theta substituted in place of cos squared, and hence splitting this separately I get this as minus 1 by 2 times integral d theta plus integral cos 2 theta d theta when I split the integrals using the property. So is what we get on simplification. Next, this is minus 1 by 2 times integral d theta is theta, and then because integral and derivative get cancelled, and integral of cos x is sin x by coefficient of x, because this is in the form of f of ax plus b. So the coefficient of theta, which is 2, comes out here, and then plus c is what we get.